today we're looking at the Spark Schools Parents, Robots and Kids, Polygons and Angles lesson. This is the second major lesson that Sphero uses with the MarcoLab. So the goal of this lesson is to learn about the headings. Sphero uses 360-degree headings, and writing a program that allows Sphero to draw a square, a triangle, and a pentagon. And this is going to help them learn, apply, and internalize math. So looking at the Common Core math standards, they've done a good job of just kind of curating all those standards right here at the beginning of the lesson plan for you. You can see all the standards you might be hitting. And the materials needed, all pretty straightforward. Now, what we end up doing is using the MarcoLab to write a program. And we can look at this program square, and we can see some things about it. We can see that each layer of this, if I click this first layer, we can see that this is a simple command. We can click more info, and it tells us a little bit about that command. So each one of these lines is a command. And we can see down here, the very bottom one, this is command number 28. So there's 28 lines of code in this MarcoLab program. Some of them change the color of the ball, some of them change the heading of the ball, some of them make the ball stop. And then there's a lot of comment ones. So the ones with the circles are actual commands, and these are just comment commands, so that you can tell what the program does at each step. What your students are going to do in this lesson is they're going to create a program very much like this, although I doubt they'll have all the comment boxes in there. But you could ask them to do that. It is good programming practice. And what they do in this lesson plan is they walk you through each step of writing this program. They even give you the screenshot. So you can see that here, this program looks considerably shorter than this one, and a lot of it has to do with the fact that there are no comment blocks. So the roll 0.2, 90, 2000, we can find the 90-degree one. Here, this one's rolling 0.5, 90, 2000. And if we look, what that means is the speed on this one is going to be 20%, 0.2, but the speed on this one is 50%, 0.5. I could bring this down to 20%, and when we go back out, we're going to see that now it matches 0.2, 90, 2000, 0.2, 90, 2000. So your students are going to use the slider controls like that to set up each of these commands. Like any good programming interface or programming activity, what we've got is an activity that starts with a very simple shape, a square, moves to a slightly more complex task, a triangle. The angles are going to be different. And then you've got the challenge. So in the challenge, they actually have you draw a pentagon. You could have your students do any other shape, all depending on their level of ability and comfort and what kind of level of challenge you want to put out there. I'd imagine you could even get them to scale things by changing the rate or the time. Once you get the angles set up, changing that rate and time can get you to scale the actual size of the shape. So this is a pretty deep activity as far as the math, figuring out what heading you need to go at in order to make that happen. Pre-drawing it on graph paper might be a good idea. Working with a compass could be some preparation, but this is really applied math. And the programming in it is a non-syntactical program. So like what we see here is we've got this block just changes the color of the robot, and we can do a different block like this one is a motion block where it's just going to be the speed, the heading, and the delay. If I want to create a new block, I can go all the way down here to the end. I can hit plus. I see my full menu of blocks. We've got set orientation, we've got rotate, stabilization, sleep. All of these things I can make the robot do, and all of them are just slider based. This can increase or decrease the amount of delay at a certain point in the program. So the students ought to be able to get creating their shapes pretty quickly. Maybe you're going to have two of them working in a group, one of them programming on one iPad, one of them filming on another one. I don't know. Lots of potential here. Looking forward to working on it with my kids.